Alright, cutting rivets. Cutting a torch is excellent for removing the rivets for the trick for being disassembled. Riveting covenant procedure shown figure 4 3 the basic method with the heat head of the rivet with the cutting temperature by heat with the preheat flame with the cutting torch. When rivet head is proper temperature for the turn on the action, wash it off. Remaining portion of the rivet can be punched out with a little hammer blows, and the step-by-step procedure as follows. 1. Use the side with the tip of the oxygen pressure required for the side with the tip of the rivet that you're going to cut. Heat a spot rivet head until it's bright red. Move the tip of the position parallel while the surface of the plate turn on the cutting oxygen slowly. 4. Cut a slot with the rivet head like the screwdriver slot with a round screw. The cut nears the plate with the draws nozzle back at least 1.5 inches from the rivet so you don't get cut through the plate. When cutting slide through the plate, that you should swing the tip through the small arc that slices half of the rivet head off. The swinging the tip of the arc in the other direction to slice the other half of the rivet head off. It shows preheating the flame. Half head sliced off, slice, cutting head and nozzle shown drawn in 1/2 inch. Remainder of the head cut off, head cutting slice. Alright, by the time the slot has been cut, the rest of the rivet head is cutting temperature for just before you get the slot drawn with the torch back 1 inches to allow the cutting oxygen scatter slightly. This keeps the torch of the breaking through the layer scale always present between the rivet heads of the plate. Allows you to cut the head of the rivet off without damaging the surface of the plate. If you do not draw the tip of the way, you can cut through the scale into the plate at low velocity. Cutting tip must be cut on the button head rivet to remove the countersinks rivet with low velocity. Cutting tip of the cutting oxygen orifice with a large diameter above the orifice of the reheating orifice. Always place the low velocity cutting tip into the torch over the heating orifice above the cutting orifice of the torch's head with the riveting cutting position. Alright, cutting wire rope. Using a cutting torch to cut wire rope. Wire rope consists of many strands. Since these strands do not form one solid piece of the metal, you can experience difficulty in making the cut. To prevent the wire rope strands from underlaying during the cutting, a seize of the wire rope on each side of the place when you are intended to cut. Adjust the torch neutral flame, make the cut between the seizing. If the wire is going through the sheaves, then you should fuse the strand wires together and point the end. This makes the revving the block much easier, particularly when you're working with a large diameter wire rope. When revving the blocks so they are closer together, fuse the point wire rope, adjust the torch neutral flame, close the oxygen valve until the carbonizing flame with the proper torch manipulation. Fuse the wires together, point the wire and rope it at the same time. Wire rope is lubricated during fabrication and is lubricated routinely during service life. Ensure that all excess lubrication is wiped off of the wire rope before you begin cutting off the oxygen cutting torch. Cutting iron containers. Never perform cutting or welding containers on held that flammable substance that have held the flammable substance until they have been cleaned thoroughly and safeguarded. Cutting, welding, any other object or work involve the heating or sparks of the unused barrels, drums, and tanks out of the container. Extremely dangerous, could lead to property damage or loss of life. When available, use the steam or use steam to remove materials that are easily volatile. Washing the containers with a strong solution, caustic soda, or some local chemical, but they remove heavier oils. Even after thorough cleaning of the container should be further safeguard filling it with water before any cutting, welding, or other hot work is done. Almost every situation is possible. Position container can be kept filled with water while cutting. It is possible to position the container so that it can be kept filled with water while cutting or other hot work is being done. Always ensure that there is a vent or outputting container for the release of the heated vapor inside of the container. This is done by opening of the bung, handhold, or other fitting above the water level. With a practice fill of the container with water, when it's practical, fill the container with water. You should always use the carbon dioxide and nitrogen into the vessel for the added protection. From time to time, examine the gas content of the container and ensure the concentration of carbon dioxide and nitrogen is high enough to prevent flammable explosives. Make sure the air and gas mixture inside of the container can be tested in a suitable gas detector. The carbon dioxide concentration should be at least 50% of the airspace inside the container, 80% or more presence of hydrogen and carbon monoxide detected. Using nitrogen, you must ensure the concentration is at least 10% of the higher than the specified carbon dioxide. Carbon dioxide and nitrogen used apparently in cleaning containers become that there may still be traces of oil, grease on their seams, even though the vessel was cleaned flush with the caustic acid solution. Even the cutting welding operation could cause the trapped oil grease to release flammable vapors, form explosive mixtures inside the container. Metal parts, especially light, may be hollow inside, therefore should vent with the part of the drilling the hole even before heating. Remember, air and any other gas can find inside that whole part will be examined. The heated internal pressure create enough to cause the part of the burst before you do any hot work. Take every possible precaution to vent and air confined in bracketed vessel tank container. Alright, judging cutting quality. To know how good the cutting job you are doing, you must understand now what constitutes a good oxygen cut. In general, quality oxygen cut is judged by four characteristics: shape, length of the drag lines, smoothness of the sides, sharpness of the top edges, the amount of slag adhered to the metal. Drag lines are line marks that show the surface of the cut, and good drag lines are almost straight up and down, as shown in Figure 431 View A. Poor drag lines are shown in 431 View B and are long, irregular, curved excessively. Drag lines of the type indicate poor cutting procedure that could result in loss of cut. Figure 431 Views B and C. Drag lines are best single indication quality of the cut made with the oxygen torch. The drag lines are short and almost vertical, sides smooth with the top edges sharp. You can be assured that the slide conditions are satisfactory. Side smoothness. Satisfactory oxygen gas cut smooth sides as a grooved fluted drag cut surface is a sign of poor quality. Alright, top edge sharpness. Top edge sharp edges resulting from oxygen gas cut should be sharp and square. Round top edges of those shown in Figure View E are not satisfactory. Melting top edge may result in the incorrect preheating procedure for the move from moving the torch too slowly. Slide conditions. Oxygen gas cut is not satisfactory when slag adheres so tightly to the metal that it is difficult to remove. Safety precautions. In all cutting operations, you must ensure that hot slag does not come into contact with the combustible material of the globe, so the hot slag can roll along the deck for a long distance. Not cut within 30 to 40 feet unprotected combustible materials. If you cannot remove the combustible materials, cover them with a sheet metal over the other flammable guards. Keep the fuel, gas, oxygen cylinders far enough away from the work so hot slag does not fall on the cylinders or hose. Many safety precautions discussed in Chapter 5 through 8 of this manual apply to cutting as well as to welding. Be sure of the complete failure with appropriate safety precautions before attempting oxygen gas cutting operations. Alright, backfire and flashback. Improper operation of oxygen gas torch cut can cause flame to go out and loud snap or pop. This is called a backfire. Close the torch valves. Check the connection, review the operational techniques before relighting the torch. You must have covered the backfire by touching the tip against the work, by overheating the tip or operating the torch with an incorrect gas pressure. Backfire may also be caused by a loose tip or a head or dirt on the seal. A flashback occurs when the burn backs inside of the torch, usually shrilling, hissing, or squealing noise. You should close the torch oxygen valve that controls the flame to stop the flashback at once. You should close the gas valve and the oxygen gas regulators. Be sure to allow the torch to cool before relighting it. Also blow oxygen through the cutting tip for a few seconds to clear out that may have accumulated in the passages. Flashbacks may extend back into the hose regulator. Flashbacks indicate something is wrong either with the torch and with the way it's being operated. Every flashback should be investigated, determined in the case causes before what torch is relighted, clogged, or if it's incorrect oxygen gas pressures are often responsible. Avoid using gas pressure higher than recommended by manufacturer. Alright, gas cylinders are made of high-quality steel, high-pressure gauge of the oxygen, hydrogen, and nitrogen compressed air stored in cylinders, seamless construction. Only non-shareable high-pressure gas cylinders may be the shape of activity operating outside of the continental United States. Cylinders with low-pressure gas, such as acetylene, may be welded to their brazed. Cylinders are carefully adjusted either by factory or design pressure station that adds pressure is above maximum permissible charging pressure. Alright, identification of cylinders, colors, warnings provided with effective meaning for the marking, physical hazards for indicating location, safety equipment. Uniform colors are used to mark the compressed gas. Cylinders may apply carrying hazard materials. Fire protection equipment, the 5 classes of materials have been selected to represent the general hazard of dangerous metals. It's yellow, brown, blue, and green, and gray, and red. You have oxyacetylene, top A, B, and C in the body, both cylinders. So, With 6 classes, shall have the reserve fire protection equipment. Standard color has been chosen to represent each of these classes, shown in Figure 4.2. Table 4.2. Since the work of the fuel gas oxygen must become familiar with the color cylinder in which these gases are contained, the fuel gas cylinder is yellow and the oxygen gas cylinder is green. In addition, color coding the exact identification material contained in the compressed gas cylinder must indicate a written title appear for the two locations diametrically opposite when the parallel to the longitudinal axis of the cylinder. Cylinders having a background color yellow, orange, buff of a little title painted black. Cylinders having the background color red, brown, black, blue, green have the title painted white. Color warnings: appearance of the body type of the bonds of the compressed gas air cylinders of the 6 colors should provide a warning of the danger of the fire hazard involved. Cylinder color bands. Cylinder color bands appear on cylinder bodies. Severe color warnings: yellow, blue, brown, green, gray. These bands provide color combinations separately distinguishing cylinders, conveyance, hand storage, shipping. Color bands for segregation purposes will be specified in the new materials presented and covered in Military Standard 101B. Alright, decals. 2 decals should be applied to the shoulder. Each cylinder should be diametrically opposite right angles to the titles. They should indicate the name of the gas precaution handling. Use background color corresponding primary warning color. Content should be used. Shatterproof cylinders should be sensible to the phrase non-shat, longitudinal 90 degrees from the titled letters. Must be black and white, approximately 1 inch size. Service ownership: 1 cylinders owned or produced by the Department of Defense. The bottom and lower portion of the cylinder body opposite the valve and may be used to serve as ownership titles. Alright, Figure 4.33, identifying color patterns of gas cylinders. You have a white oxygen medical, green oxygen aviator, and oxygen green. Brown is helium oil-free medical, and the color is gray. Gray, red, green, helium oil pumped. Brown, white, green, helium oxygen. Black, yellow, hydrogen. Yellow, acetylene. Carbon dioxide, gray. Carbon dioxide fire only, red. 6 colors identified with the table 4.2. You view the body with the top of the band of the compressed gas cylinder. Serve the warning that has been involved with the handling type of the material contained in the cylinder. Figure 4.32 show the title and color codes compressed gas cylinders most often found in construction, installation, battalion, public works department where CB personnel are working. Figure 4.33 show how cylinders are identified, overall paint and color code, and single name of the gas for the complete line listing of the compressed gas cylinders and refer to Military Standard 101B color code pipeline compressed gas cylinders. Note: ensure your manual latest up-to-date change with an inserted change might occur with the Military Standard 101B after this manual is published. Should noted with the color cord cylinder shown in Figure 4.32 of the military only. Commercial and industrial does not necessarily comply with the color codes. Handling storage gas cylinders. Each compressed gas cylinder marking with it indicating compliance with the Interstate Commerce Commission requirements. The cylinders are at work site and they may become responsible. There are several things you should not when handled with a storage compressed gas cylinder. Never fill your own cylinders. It requires special training and special equipment. Never alter fixed safety devices on the cylinder. Illegal, also stupid. The only person permitted to work on the cylinder safety device are the cylinder owners and operators, suppliers. Never store cylinders near a heat source or in direct sunlight. Heat causes the gas inside of the cylinder to expand and could result in cylinder failure of the fire. Never store cylinders in an enclosed, unventilated space. If the one cylinder were to leak, it could cause an explosion. Approximately fixate someone entering the space and store cylinders protected, well ventilated, and dry. Space to protect the cylinder valve, safety devices, ice and snow. Safety device may not work in the frozen if it is frozen. Never store fuel cylinders, oxidizers in the same place. Oxidizers must be stored at least 50 feet from fuel cylinders on fire-resistant portions between cylinder storage areas. Never mix empty cylinders with fuel cylinders. Do not mix cylinders with contain different gases. Always replace cylinder cap marked with the cylinder empty or MT. Store cylinders in a cool, dry place ready for the pickup of the supplier. Even the stored chain cylinders when they are stored in the upright position. Never drag cylinder or to move the available to the cylinder truck. When available, use the cylinder truck. If possible, leave the cylinders on a hand truck. Operate them from there. Otherwise, tilt the cylinder slightly, roll it onto the bottom edge. Always install the cylinder cap before moving the cylinder. Never use slings magnets to carry cylinders. If you lift the cylinder upright by a cap, make sure it is screwed on tightly. If the cylinder cap comes off, the cylinder could fall and either crush your foot, snap the valve off. If the cylinder is dropped and the valve breaks, it could launch itself into like a rocket. And when cylinders have been stored outside of freezing weather, sometimes become frozen to the ground to each other. This is true particularly with the Arctic areas. To free cylinders, you can pour warm water, not boiling over the frozen icy areas. As the last resort, you can pry them loose from the pry bar. If you use a pry bar, never pry or lift under the valve cap or valve. Chapter 5, Gas Welding.